All right, if we're asked to differentiate this, this is a product of two functions, first of all. So I'm going to see a little bit of a product rule here. But I'm also, when I'm taking the derivative of the second one, I also see a little chain rule going on. So I have an outside function, and then I have an inside function. See that? So we have two. We have the product rule and the chain rule going here. All right, you ready to brace yourselves? Okay, f prime of x is going to be, the product rule has to come first here. So the derivative of the first times the second plus the first times the derivative of the second. So that's where we got to do now chain rule. So you might want to rewrite this whole thing as x squared plus 1 to the 1/2. Remember, it's a little bit easier to see how we use the power rule with a fractional exponent as opposed to having the root sign. So as long as you know that's what that is, you can go ahead and go like this now. 1/2 times, I leave this inside function alone. I subtract 1 from 1/2 to make that negative 1/2. And then I multiply by the derivative of the inside function, which is 2x. Nice. So this is the unsimplified version of your derivative. That's your derivative. That's one step of differentiation only. If we were asked to simplify this or, go further, then you could do, you have to work on the right side a little bit, right? So this is going to be x times 2x. So that's going to be 2x squared. And we're going to have this 2 and this part of the function underneath in the denominator. So that's going to be 2 root x squared plus 1. And of course, if I have 2 over 2, you're going to be able to get rid of those. And if you want to fully simplify, we could actually add these two together. It's not a big deal. That's not too hard. All I do is multiply the top and the bottom by root x squared plus 1 to get a common denominator. I can get one term here, which would be part of our full simplification. So on the bottom, we just have root x squared plus 1. On the top, when you square a square root, like we did up here, that just becomes x squared plus 1 plus x squared, 2x squared plus 1 over root x squared plus 1. And that would be fine to leave it like that. Radicals in the denominator is okay. Get it to one term, that would be fully simplified. No other factoring to do on top or bottom simplification on in those areas, so you're good to go. That should be good. Okay, how you feeling about that one?
I can live with it.
You can live with it? Iffy, kind of, crazy, so. Okay, you're all right? You're not dying back there? Okay. Shall we do another one? Yeah. Yes? All right. Let's see. Did this one here. Ooh, let's do a quotient rule one. Let's do E. Wait, what? Let's do E. All right, let's do this one. I've got a summary of the differentiation rules here coming up too. I'll show you after this question. That's all of them. That's all of them right there.
Oh, no.
Yeah, that's gonna be great. You should buy that poster off Amazon and put it in your bedroom.
Just different reactions. Oh, that's helpful. That's really gonna make you good.
And then some people are like, I'm gonna die. Okay. Okay, so this one I see quotient rule, and I also see chain rule because of the function within a function here. So let's do this thing. F prime of x is going to be quotient rule. Let's do that. That's the big picture. So let's do derivative of the top, which is just 1 times the bottom, root 2x plus 3, minus the top, which is x times the derivative of the bottom. Okay? So we're big kids now, so we can find the derivative of this. Chain rule, I'm going to do 1/2 times 2x plus 3 to the negative 1/2. And if you don't like what I did there, remember this is what I did. 2x plus 3 just to the power of 1/2. That's what this actually equals. Okay? And then I got to multiply it by what?
2.
2. Right. The derivative of the inside function, which is just 2. And I can't forget, because I'm still doing quotient rule, that I have to square the bottom. Ooh, that's going to be actually kind of nice. 2x plus 3, root 2x plus 3 squared. Ah, that's going to make for some simple simplification. Okay. Now, if you were asked to just take the derivative, do not simplify, that's where you stop. You just show me that you've done quotient rule and chain rule. That's it. You're done. Okay. But most of the time you're going to have to simplify.
Is the quotient rule times 2 or you got that?
The quotient rule times 2, well, this times 2 over here, you mean?
Yeah.
That's part of the chain rule. So
Oh,
I had this outside function,
Yeah.
inside function. So I'm multiplying by the derivative of the inside. That's where this 2 comes from. Okay, so this is square root 2x plus 3. And this over here, the 1/2 and the 2 actually cancel out. And I've got a minus, I've got x over root 2x plus 3.
Why would that cancel out?
Because you've got 1/2 times 2. So it'll be 2 over 2, it'll be just 1. And the square root and the square also cancel out, yeah?
Isn't it outside of the brackets? Like, so, oh no, it's inside the brackets.
Yeah, it's technically inside of these brackets, which I didn't put down there, but yeah. That's all one multiplication term there. Yeah. Okay, so there you go. For simplifying, that's not a good way to leave it either. So we should simplify the top by doing this actual subtraction. So I'm going to multiply top and bottom by root 2x plus 3, which is going to make a squared up top there. Okay, so that squared and this square root are going to go away together. I'm going to have, ready for this? I'm going to have 2x plus 3 minus x up top. And because I've got a common denominator here, and I'm also dividing by this as well, I can actually put this 2x plus 3 and the root 2x plus 3 on the bottom together. And this is going to be x plus 3 over, now you guys are going to probably hate me here, but we should simplify this. Why should we simplify this? We can simplify this because guess what? This is the same base, and we're multiplying together. This is to the exponent 1, this is to the exponent 1/2. Sorry, there's a funny look over there. Look at, if you have x to the 1 times x to the 1/2, what do you do there? That's x to the 1.5 or 3 over 2. So guess what? This is just some random base. So guess what? This is actually 2x plus 3 to the 3 over 2.
So, when you do that, you...
Add the exponents.
Yeah.
Add the exponents. Now, if we don't like fractional, I don't like fractional. I'm not sure what the official rules are, but root 2x plus 3 cubed would be a good idea. Wait a minute. 3 over 2. 1 plus 1/2 is 3 over 2.
Yeah, that's right.
You can get yourself into a little bit of a circle here. I get it. This is what's tricky about this, because when you have a square root that's cubed, like, check this out. You could actually, if you have a square root that's cubed, you could actually simplify part of that. That's x root x, but that's where we started. That's what we started with. So you could get yourself into a little bit of a circle there. So don't stress out. This is good, right? You could actually keep going back and forth. When am I simple? I'm definitely simple-minded right now, but so that would be, I think, a good answer there. Let's just check the back of the book, see what they have to say.